Okay, so here's the tricky part. When I go to do my one prop z interval, I can't put in, I don't have a number, I can't put in 76.9, I get an error. I definitely can't put in 0.769, I get even more of an error, or the same error. So I got to figure out what is that. That's x. It's the number of people who said yes. How do I find that?
You would multiply 745 times 0.769.
Perfect. And when I do that, I get 572.9.
Yes.
But again, you can't ask 572.9 people. You have to round to the nearest number, nearest whole number.
Yeah.
573.
Mm-hmm. So then that's going to be my x, 573. Okay, is everyone done with this one?
Yes.
Okay, add a 745.99, and what did you all get?
0.729, and then 8.0808.
809, right?
Yeah.
Okay,
Perfect.
good. It also gives you the point estimate. Oh, actually, you have the point estimate. It's given to you right there, 76.9%.
Perfect.
And then we have to find the margin error again, which again is going to be
0.7769 minus the lower limit.
0.040.
Perfect.
Okay, great. Good. All right. So I did want to also go over this first for a minute and review correlation. So it's been a little bit since we've seen this problem. So I'm going to give you folks, try 15 seconds on your own without talking first, and then we'll do 15 seconds talking to your neighbors. So first 15 seconds on your own. All right, which one's 100?
None.
None of them. Remember, it only goes up to 1 and down to -1. So these are all impossible. So let's do the easy one first. What's this perfect line? 1. And the one below it?
-1.
And then this guy over here?
0.
Great. These two are both positive. This one's more like a line, so it's closer to 1. It's 0.8, which means this one's 0.6. And then these two, this one's more like a line, but it's negative, so it should be closer to -1. So it's
-1.
yep, which means this one's -0.5.
Yeah.
Okay, good. So now we're back to the packet. Number 1 in the packet. Score of 20 games is given below. Find the range. And then make a frequency distribution chart for this. So again, the range is the max minus the min. I have them highlighted for you. What are those?
68.
68 minus 8, 60. So now try to figure out what your class limits should be. What do you think? All right, let's think about this for a second. I have my range of 60, and to figure out what my class width is. Ideally, what size class widths do we want?
5 and 10.
5s and 10s and 20s, right? Does that make sense? People remember that? Put 5s and 10s and 20s. So in this case, which size with a range of 60 is going to make the most sense to use? 10. When you can, do it 10. So because if I take 60 and divide by 5, I get 12. That's close to 10. Right? You should get something that's, so if it's around 50 or more, 10's good. Close to 50. If it's close to 25, then you might use 5. So we have a class width of 10. So keep that in mind as you do these. Okay, folks, so sort out your first class, lower class limit. Everyone find the first lower class limit. Find it. What is the 10 that is below? What's my minimum?
8.
8. What's the 10 that's below 8? 0. Should start with 0. Remember, the idea of these class widths, why we want to have a class width of 10 or 5, is so that we have our limits are pretty, so people don't have to spend time wrapping their heads around the class limits. The limits make sense to them, they're familiar, and they can focus on the data, which is where we want them to focus. So the class limits should be pretty so that people don't get distracted by them, and they can focus on what you really want them to focus on, the information. So the first lower class limit should start with 0, and again, the next step you want to do is find all the rest of the lower class limits, and then find the upper limits. So what's your next lower class limit?
10.
10. Yep. All right, so if we take a look at all the lower class limits, 20, 30, 40, 50, 60, 7 of them. And then you go back and then you backfill what it goes to, right? So before 10 is 9, 19, 29, 39. The useful thing about this too is then it makes it really easy to figure out your counts. I don't even need my tallies because I can just say, oh, which one has no numbers in front? Just 1, just the 8. Which one starts with 1s? 1, 2. 2 start with a 1. Which one start with a 2? 1, 2, 3, 4, 5, 6. Right, so that's the thing that's really useful about having it like this, because then you have to worry about, is it 21? You know, you don't have to go from like 11 to 20, because it's just harder to sort that out. Or again, you can tally them up as you kind of go through. The tally is optional. It's just that kind of the markers as you're counting through on them. 30s, I have 1, 2, 3, 3. 40s, 1, 2, 3, 4. And then 2 of each of the other ones. All right, so everyone has this so far? Then you have to find the relative frequencies. Remember, relative frequencies, that's how it relates to the whole. It's the ratio, relative starts with R, ratio starts with R, the ratio of what's in that class compared to the total. How many are there total? 20. So the first one would be 1 over 20, or 0.05. Next one would be 2 over 20, 0.1, 0.3, 0.15, 0.2. It's also kind of the percent that's in that class.
It's equal to 100%, right?
What was that? It goes up to yeah, adds up to 1.
Yeah.
Yeah. And then cumulative frequency. Cumulative is like snow accumulating on the ground. You add more to what you have. So I have nothing, and then I add 1. I add 2 more. I add 6 more. Add 3 more. Add 4 more. Add 2 more. And add 2 more. So at the end, you should have your total. Okay, everybody all right with this part? Okay, work on problem number 2. Problem number 2. Oh, we did that. No, it's 20. Sorry, my bad. Problem number 2. There we go. What kind of problem is this?
This is the normal distribution problem.
Yeah, it has z-scores. It has a normal distribution. And what's it saying? Use the what?
The empirical rule.
Empirical rule. That's for normal distributions. It's that estimate. Right? It's that thing where you have this and you kind of jump this way. Does everyone kind of remember that one? You jump that way. Empirical rule. It's also known as the what rule?
Normal.
I don't see the
Nope. 68,
95.
95,
99.
99.7 rule.
Oh, 99.7.
So we're approximating. So again, you're using the empirical rule. We have our center. What's in the center? Our mean. What's our mean?
37.
37. That's in the center. And then from there, you're going to kind of jump out. Standard deviations in the direction. Let's see where we're at. So, so I have my mean, that's in the middle, and then I'm going to jump standard deviations to the left and the right. So I'm going to subtract 7, subtract 7, subtract 7, that direction, or add 7, add 7, add 7 in that direction, which is going to get me to, from 37 minus 7 is 30, 23, 16, and then add 7, 44, 51, 58. So, between 23 and 51, that is two standard deviations in either direction. That is not the answer. The answer is, what's a percentage? So what percentage goes with 2 standard deviations? 95%. And then 68% should be within 1 SD. So yep, that's 30 to 44 ounces. Good. And the last one, Snowball the hamster. Find his z-score. A z-score represents the number of
standard deviation between the mean and
almost standard deviation's value is away from the mean.
yeah.
So how do you find a z-score?
Isn't it not the mean minus
X minus the mean
oh x minus okay.
divided by
The standard deviation.
standard deviation. Yep. That way, if it's above the mean, it's positive. If it's below the mean, it's negative, which is how it should work, right? So what was Snowball's z-score? His value minus the mean divided by the standard deviation.
Negative 0.7143.
Yep, negative 5 over 7, which you said was negative 0.714. Good? Great. All right. Nice. Now we're going to move on to problem number 3.
Let's go.
Oops, it's out of order. Oh no, this one must be out of order. There we go. We're going to skip the mean, because mean is just obvious, right? We all know how to find the mean. Find the median and the mode. Okay? So the median is the number smack dab in the middle when you put your data in order. If you don't put it in order, you're going to get garbage. So first I have to put it in order. And then find the one smack dab in the middle. So my median is 1. What's my mode?
1.
The one that occurs the most? Also 1. Good. All right, moving on. Problem number 4. There we go. GPA problem. So on the exam, I may not have it. If I do this on the exam, it may not be where I add up all the A's for you and the B's for you. It might be like each class individually, so you might have a couple A's or B's in there. Remember the A's are worth how many points each? 4, and then B's are worth 3, C's are 2, D's are 1, F's are 0. So really this is like having 8 credit hours of A is like having 8 little 4s. You have a 4, you have 8 tiny ones, 8 tiny grades of A. So go ahead and figure out how to compute the GPA, the average grade. Okay, so remember if I have 8 little 4s and 4 little 3s, if I want to add up 4 8 times, I can just do 4 times 8. If I want to add up 3 4 times, I can use 3 times 12. All this does is give us a shortcut for adding them all up. That's all it is. Shortcut for adding up 8 4s and 4 3s and 5 2s and stuff like that. We'll get 60. What is the 60? It's 60. How did I get that? I multiplied my grades, my grade points, times my credits. So is my GPA 60? No, I need to divide by something. So do I want the average grade or the average credit?
Average grade.
average grade, which means I need to cancel out, I need to get rid of these credits. I need to divide out the credits. So it means I need to figure out what my total credits are and divide by that. You can also think of it like this. What you should divide by is a thing that doesn't change from person to person. So this class is a four-unit class. What varies from person to person? Their grade in this class or the number of credits this class is worth. Their grade. You do not divide by the thing that varies from person to person. That's what you want to keep. You divide by the thing that stays constant from person to person, the credits. So that's 25. Divide by 25 and you should get
2.4.
2.4. Yep. So we're going to come back to number 5. I want to jump to number 6 first. Since you folks are leaving soon, because I want you to get exposure to this one. What kind of problem is this one? It's a probability problem, yes. It says find the probability. It's a probability problem, so it's going to be chapters 4, 5, or 6. So what's up with what kind of probability is it? What do I have there? I have a percent. 32%. So 32%, that's a proportion, right? I have a proportion with a probability. What do we call those? What were those? The ones that were percents, probability, proportions with probability. Similar to a proportion. Proportion, what did we deal with that were like proportions in chapters 4, 5, and 6 with probabilities? Binomial, exactly. Binomial. So binomial, this is a binomial problem, which means that it's either one or the other. You either are or you aren't. So if 32% are, then what percent aren't?
1 minus
68%. So this is going to be binomial, which means we're going to be using binom PDF or binom CDF. What's the difference between them?
CDF is cumulative.
Yes, CDF is cumulative. The C here, that means cumulative, which means you're adding them all up. So it means it's a probability of 0 plus probability of 1 plus probability of ... up to whatever you stop at. Whereas the PDF is just a probability of exactly
8.
that number, yeah, whatever number. Probability of exactly X. Whatever your X is that you picked. So the first one, the probability of exactly 2 have a college degree. Which one am I going to use? PDF or CDF?
PDF.
PDF. Binom PDF. Now, we need to have binomials, they're all defined by their n and their p. So what's the n and the little p for this problem? Everyone find the n and the little p? What's the n and the little p? N is 8. Little p is what? 32% or 0.32. Good? So then what's my little q again? 0.68. Yep. All right, so binom PDF of it's n, comma, p, comma, x. So in this case, it would be binom PDF of what? Plug it in, give me the answer, and then take a gander at B. How do you get to binom PDF? So first of all, it's binom PDF of what? N is 8, little p is
0.32,
and my x is
2.
2. So binom PDF, we get there by second bars. Folks remember second bars? So everything is going to be either second bars or stat something. Second bar is arrow up because it's towards the bottom. Binom PDF. And again, you're going to put in your N, comma, your little p, NP, and then X, 2. You get 0.2835 when you round. And the next problem is less than 3 have a college degree. Less than 3 is how many people? 2 or 1 or 0. So here, am I going to use PDF or CDF?
CDF.
CDF, because CDF gives you 0 up to that number. So where am I going to stop?
2.
2. So it makes sense. I want 0 up to 2. So you're going to do binom CDF and write in what you think should go in there. CDF of what? Yeah, the exact same thing. The only difference between the two is that one's CDF, the other one's PDF. So how does that work? Second bars, arrow up again because it's towards the bottom. CDF, 8, comma, 0.32, comma, 2. So it's exactly like the one above, only difference is it's CDF instead of PDF, and you'll see you get a different number because you're adding in the probability of 0 and the probability of 1. Finds the probability that x is 0, finds the probability x is 1, finds the probability x is 2, and it adds them all together. That's what CDF does. So then we get an answer of 0.5013 when we round. Okay, everyone feeling all right with that part? Now, the at least one. At least one. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Which ones are at least 1?
Anything above 0?
Yep. All of these guys. So I could find the probability x is 1, plus probability x is 2, plus probability of x is 3. I can do binomial PDF of all of these and add them up. Or probability of at least 1 is equal to 1 minus the probability of 0. Right? Because so all these together have to add up to 1 or 100%. So if I want the stuff in blue, I can just do 1 minus the stuff that's outside. Probability that x is 0.
Got it. So you got 0.95.
So it's going to be 1 minus the probability.
You got this right.
1 minus the probability of
Yeah, perfect.
0. In other words, 1 minus binom CDF. CDF or PDF, either one's actually okay because it's just the same thing. In this case, CDF, PDF, CDF of NX, so NP, what should go in there?
0.
Yep. And you can just do all that on your calculator if you like. I can just do 1 minus second bars. Right, so I have the 1 minus there. Binom CDF of 8, comma, 0.32, comma, 0. I get 0.9523. Sorry. And the last one is this. The mean and standard deviation. So remember, binomial distribution is my favorite distribution because the mean and standard deviation are the easiest to find. They're super easy. My mean is just what? Anybody remember? NP. Yep, my mean is NP. And my standard deviation is equal to
NPQ square root.
NPQ. Square root of NPQ. So that's equal to 8 times 0.32. I'll let you folks do it. All right, so NP is 8 times 0.32. So you got, is it 2.56? Is that right? And then this one is square root of 8 times 0.32 times 0.68. And you got, what'd you get for that? 1.28? 32? Who got, what'd you guys get?
1.32.
32? I think last class got 32 as well. Just double check your numbers, it's okay. All right, sounds good. All right, so let's take a quick break. And we will come back in 10 minutes.